In this video, we're going to look at fundamental pieces of computer hardware known as logic gates and how they can be used to build circuits. We've already talked about how all data in a computer is stored as collections of bits. And when designing a circuit, we're going to think about those bits as Boolean values, where 1 is equivalent to the Boolean value true and 0 is equivalent to Boolean false. In Python, we've used logic operators, and, or, not, to build up Boolean expressions. And in circuits, there are corresponding pieces of hardware called logic gates. And let's look at each of them in turn. The AND gate, when we draw it, is shaped the way you see here, so that there's a straight edge on one side and then a curved edge on the other side. We have some number of input pins or input wires coming in to the straight edge, and they're going to take on a value of either 0 or 1. And then there's a single output pin, and it will have the appropriate value 0 or 1. And the way this works is very much like what we saw with the AND operator in Python. So the AND gate is only going to output a 1 if all of its inputs are 1. And this is just like the AND operator, which only gives you true if all of the component Boolean expressions are true. And we can summarize the behavior of the AND gate by labeling the inputs, so here I'm labeling them X and Y, and then creating a table in which we show the output for all possible inputs. So when X and Y are both 0, AND is going to give us 0 because neither of them is 1. If X is 0 and Y is 1, again we get 0 because they're not both 1. Same thing for X1, Y0. And the only place we're going to get a 1 is when X and Y are both 1. This is known as the truth table for the AND gate, and you can think of this as being a Boolean function, a function of bits, where for a given set of inputs, the function gives us the appropriate output. And again, just to emphasize here, we're only getting an output of 1 if all of the inputs are 1. The OR gate is drawn as you see here. There's a curved edge on one side where the inputs come in, and then there's a pointed edge where the output goes out. And the OR gate will output a 1 if any of its inputs is a 1. Here's the truth table for an OR gate with two inputs, X and Y, and you can see we're almost always getting a 1. We only get a 0 if both X and Y are 0. The NOT gate is drawn like this. It has a triangular shape. It can have a bubble here at the point of the triangle. It takes a single input in, and it gives you a single output that is the reverse of the input. So here's the truth table for it. When X is 0, you get 1 for NOT X. When X is 1, you get 0 for NOT X. Circuits are formed by combining logic gates, like you see here. Let's trace through what happens when X is 0 and Y is 1. Let's focus first on this AND gate. So the X value of 0 comes down, but before it hits the AND gate, it's passing through this NOT gate, and that's going to change its value to 1, and that gets fed into the AND gate. The Y value of 1 also gets fed into a NOT gate, so it gets changed to 0, and then those two inputs get sent into the AND gate, and because they're not both 1, we're going to have an output of 0. Now let's look at the other AND gate. Here there are no NOT gates preceding it, so the X and the Y are fed in as is, 0 and 1. But again, because they're not both 1, we're going to get an output of 0. Those two outputs, the outputs of the two AND gates, are then fed into this OR gate, and because neither one of them is a 1, because they're both 0, the output is going to be 0, and that is the output of the entire circuit. So we just determined that when X is 0 and Y is 1, the output of this circuit is 0. If we do that same procedure for all possible combinations of inputs, we then form a truth table for the circuit as a whole. And just like we saw with our individual logic gates, the circuit here is acting as a Boolean function, a function of bits. It takes 2 bits as inputs, and it produces the appropriate bit as output. Other circuits can take other numbers of inputs, so you could have 3 inputs, 4, and you can have multiple outputs as well, and we'll see that in lecture.